Welcome to Selected Advanced Math for High School.
Hello, welcome to our high school math session. In this session, we'll be discussing rotating a vector in two dimensions. More specifically, we'll talk about the relationship between the original vector and the rotated vector. First, I want to say what's the prerequisite for this video to understand it properly. You need to know very basic trigonometry, sine theta, cos theta, sine square theta plus cos square theta equal to 1 and so on. Also, you may need to know very basic ideas about what a vector is in two dimensions. I would suggest that you know these things a little bit, you carry on and try to follow the logic. So suppose now you have a vector 3, 1 and you rotate it by 30 degrees anti-clockwise. Remember that a vector 3, 1 means an arrow from the origin 0, 0 to the point 3, 1. What are the new coordinates of the rotated vector? The original coordinates were 3, 1. After rotating it by 30 degrees, the vector has a new tip of the arrow, so to speak. And we would like to know the new coordinates of the rotated vector. Now, in general, suppose you have a vector x, y, and you rotate it by an angle theta anticlockwise, so that the new vector, rotated vector, has coordinates x prime, y prime. We would like to know, and the key question really is, how are x prime, y prime related to x and y and the angle of rotation theta? Okay, with this we'll proceed now. We'll first make an assumption. And the assumption is that the relationship between x prime, y prime and x, y, the relationship is a linear one. In other words, we'll assume that x prime, y prime are related to x and y via linear equations. Now, that means that x prime equal to a times x plus b times y. Notice that there is no quadratic, there is no other function, just plain linear equations. Y prime equal to cx plus dy. What are a, b, c, d in these equations? They are constants in the sense they don't depend on x and y, but of course they depend on the angle theta. So we'll come back later if we have time and justify this assumption that we made here. It's a very important justification and very natural one too. Okay, so now we have to find these a, b, c, d, and please do not again forget that dependent on the angle theta. So depending on how much you are rotating it by, your a, b, c, d's values will be different. So we have these equations: x prime equal to ax plus by and y prime equal to cx plus dy. And now notice that if you have a vector 1, 0, which is the solid red arrow, if you rotate that by an angle theta, then the new coordinates of the new vector becomes cos theta, sin theta. Because 1, 0 is a unit vector, it will keep rotating on the unit circle, and it's the definition of the angle theta that the new coordinates are cosine theta and sin theta. So now you can plug in for x prime, y prime, cos theta and sin theta, and 1, 0 for x, y, and you'll get these equations. So in particular, we're actually now beginning to determine the values of the a, b, c, and d. In particular, you notice you say x equal to cos theta, so you get cos theta equal to a times 1 plus b times 0. 0 because the coordinate of the original vector was 1, 0. So you get a equal to cos theta. Exactly in the same way, by plugging in the values of y prime, which is the sin theta, you get sin theta equal to c times 1 plus d times 0. So you get sin theta equal to c equal to sin theta. So we started out with four unknowns, A, B, C, and D, all dependents on theta. And you can explicitly see here, A has become cos theta and C is sin theta. So our equations, which were, as they are shown here, have now become this. So you need to now figure out what are B and D. Now, notice that the vector cos theta sin theta, this is the vector you got by rotating 1, 0 by theta, angle theta. If you rotate it cos theta sin theta by 90 degrees minus theta, you will get the vector 0, 1. So in other words, in these equations, we'll now plug in 0, 1 for x prime and y prime. That is x prime equal to 0 and y prime equal to 1. And cos theta sin theta for x and y, which means x equal to cos theta and y equal to sin theta. However, important thing to remember is that you are rotating by an angle not by theta here, but by an angle 90 degrees minus theta. So in the above equation, where you have cos theta, you should really put cosine of 90 minus theta. Where you have sin theta, you have to put sine of 90 minus theta. So if you plug this in, what you get, for example, you plug in x prime equal to 0. So you get 0 times cosine 90 minus theta, because you're rotating by 90 minus theta, times cos theta. Why cos theta? Because x was cos theta. Similarly, plus b times 90 minus theta times sin theta, because y was sin theta. So if you equate this, then you will get b 90 minus theta is equal to minus cos theta. There is a minus missing there. We'll correct it in a moment. So you get b equal to, so let's put that minus sign in there. So this becomes minus cosine theta. Okay. And you get b theta equal to minus sin theta. Similarly, we plug in y equal to 1 and x equal to cos theta, y equal to sin theta, and you get a solution for d, which is d equal to cosine theta. Here we have used the fact that sin square theta plus cos square theta is equal to 1. Okay, I leave these detailed calculations to you. You can pause the video here and try to figure out. Moving on. Okay, so putting it all together now, we see that the question that we have originally asked, how are x prime, y prime related to x and y? We have got the solutions because we have found the values for a, b, c, and d as functions of theta. And the final answer is x prime equal to x cos theta minus y sin theta, and y prime equal to x sin theta plus y cos theta. So I guess that is the end.